uncertainty will be about how we now take our three elements that we have said interact with each other, and now that we've also talked at the very beginning about how to consider many different options in market, implementation, and technology in order to try to converge on a new innovation. And so what we're going to do now is say, all right, fine, we've opened up our mind to new application areas in addition to existing ones, and we're going to look at a wide range of technology and science that might address that, and we're going to have ideas on how business models may change, and all those things can come together and create new, really added market value, top line revenue type producing innovations. And so now that we've said that we have those elements and they interact, how do we reduce the uncertainty? Because you can't obviously leave them that uncertain. We have to bring them together and narrow them down. And so this lecture series, which is in 3 parts, is going to be describing how you start to reduce the uncertainty in each area and hopefully force the convergence of the general idea into a specific innovation that is progressing towards hopefully the marketplace, making it a real innovation. So there will be 3 parts to this lecture, beginning with talking about the process of reducing uncertainty, then after lecture 6 we'll be moving on to talking about how this process has to repeat itself several times, and that'll be lecture 7, which is iterative innovation. So the 2 are a pair, but lecture 6 concentrates first on sort of one cycle of reducing uncertainty, where lecture 7 is about how we have to repeat that many times if the idea is probably very fundamental and valuable. Welcome to lecture 6.1, Reducing Uncertainty. The first part, 6.1, will be the process and graphical representation. That will be doing, again, it's taking our same graphical representation from before, talking about the process of reducing uncertainty, and then building that up into our final innovation picture. As mentioned, this complements the next one, which talks about the iterative process as well, and also incorporates that into the graphical picture. So here's our beginning graphical representation. Remember, at the end of last lecture we said that, all right, now we have the areas here that represent the uncertainty that we're considering, maybe in order to be more innovative, more market applications in the future and current ones, and then we're considering the different technologies and key pieces of research we'd have to do maybe in order to make what appears to be the right set of things over here. And then over here we have to be thinking about future ways in which, while we're doing all this, the industry may change its structure. There may be new business models being incorporated, costs are going to be changing, et cetera, et cetera. So, all these things need to be considered. And we mentioned at the end of last time that these arrows represent two-way interaction and that they all influence each other. And we gave a few examples of how thinking about different technologies obviously apply to a particular set of potential markets, and vice versa. If you start throwing these out, you're going to have to throw these out. And so that's what we want to talk about today, is that how do we start this process? Your mind does it kind of automatically if you're innovative, but to understand whether you want to do this process or you want to work with others that are doing it properly, or whether you want to invest in those that are hopefully doing this process correctly, we need to maybe come up with a little bit more formal mechanisms, breaking down what people that naturally do this are actually doing in their minds. And so that's what we're going to talk about today. So usually people start reducing the uncertainty. If you look at innovators, they head to the most uncertain area, at least if they're trying to really have impact. Sometimes people stick obviously to one area, one element here, because that's where they want to spend all of their time. but of course that's at the peril of not really developing a real innovation. So, you know, for a researcher, oftentimes the technology is the first place. If they're smart, they've already thought about maybe a wide range of applications that they could potentially impact, so that they're not taking too high risk. There's a tendency to justify their work very early on to pick a very specific market today, and then that market, of course, by the time the innovation's finished, has changed or has gone. So for someone who's thinking a little bit further out and they require some deep research to kind of put some missing pieces together over in the technology area, they're going to want to pick one is they want to pick a problem over here, a set of technologies and sciences that can potentially impact quite a large different area of application. And if they pick something very, very specific, it's going to probably be difficult to converge everything else on those over a period of time, because this one little red dot they might be converging on might change. But anyway, so the researcher probably has some vague idea over here, hopefully a more careful thought out range of applications that in the back of their head is kind of constantly interacting with their research results and everything else. But so they're going to spend a lot of time after that initial motivation from particular application space. They're going to spend a lot of time probably over in technology, de-risking that first. Of course, that's today, as we'll talk about later, the innovation environment in the United States in particular has shifted, where probably such a person is mostly sitting in university, which affects their knowledge of implementation and market, since the university doesn't actually do these things. So that's one potential issue. Of course, the opposite is true for corporations today. If you have, if you look at company personnel today, not before, but these days, they look at it as, hey, our corporation needs to find new market space, and we don't really know a lot about these applications in different areas. And so maybe this is where they start and want to really kind of narrow this down first, just because it's kind of right in front of them, and their organizations today are kind of really geared up to be thinking about these things. Or implementation as well, a little bit more risky, but many corporations are saying, hey, maybe we'll shift our business model. Maybe we'll, do what everybody else is doing in outsourcing. Maybe we'll create a new hybrid model. These things are all in implementation. And so they may be starting, because it's on the business side, and corporations have largely hoped that someone else supplies the deeper technology side, and hopefully they imagine they can have everything they need in the ether to purchase for their future, which is highly unlikely, but that's kind of the state of affairs today. So they'll probably start in one of these areas. But regardless, you want to start narrowing it. So graphically, you could say that the company personnel is concentrating on the market or the implementation first, and the yellow ring here is just meant to show that that the focus, even though you have the other elements in your mind, the focus is on that ring at the moment. Okay, so the technologist starts probably focusing, and it makes sense too if the researcher is doing a great job on early iterative innovation, which we'll talk about the iteration part later. Then they can stay here a little bit and kind of hone in which purple dots are really relevant, and what they look like as their research proceeds, and you throw things out, put some other things in, whatever. So the researcher, which, like I said, these days usually at the university, tends to focus there, where the corporate person might focus on market and implementation, and try to narrow that initially. So regardless which element is chosen, the way that you actually do this process is through learning and abstraction. If you think about it, that's the only way we can kind of introduce, it's the only method in order to reduce uncertainty when we purposely introduce uncertainty in order to look at wide ranges of potential market technology and implementation, right? So the way we do this is learn enough about one area, right? Remember I was saying it's for the corporate guys kind of learning in this area, and this area is a little bit more natural, where for researchers it might be over here. But anyway, the point is they're trying to narrow uncertainty in one of these first. Abstraction is necessary because you can't, in any of these areas, as you're trying to initially reduce it, you can't know everything about it. So for example, if you're in a corporation looking at new markets, you can't run out there and do a full study on every single possible market application. You have to learn enough to know what to throw out, and that you've reduced it enough that then it gives insight into what technologies and implementation are possible. So you kind of want to reduce it enough that then it kind of forces the thinking into one of the other elements, and that's an abstraction, right? You actually need to stay above a level. You're bringing down, information. You're getting more detail. You're collecting more information, but you don't spend a lifetime dragging out every detail possible. And of course, there's room for error there, in which case, the iteration part we'll talk about later will probably, fix that if you're aware. So again, learning is the first step in each one of these areas, but remaining at a level of abstraction as soon as you can jump into the next element that has the highest degree of uncertainty. So just kind of summarizing this in the next view graph here, to make it absolutely clear, is shown here. So if I look at let's use the technical example. All right, we're at some place doing technology and science, and let's say that we're focusing a little further out, so there's greater uncertainty, and we're in a university, let's say. So we'll learn the technology and science that are involved, but this would be at a stage like, suppose I'm thinking about, it looks like there's a research project that might need to be done because it could unleash a lot of market applications, but I need to, before I even delve into that particular area of research, I want to learn about what's going on in that space, because my preconceived notion about what's important that I just hear from other colleagues that may be separated from a lot of the real input from the marketplace, we'll talk about that next, may not be the best way. I have to bring my own reality in through my own connections. The same could be said if I'm not working that far out. Imagine that I'm in a corporation, and maybe I'm not doing further out science and technology, but I want to know what's coming in a 5-year time scale. Well, I have to learn about the science and technology components, and to really understand what could possibly be coming, and that could include talking to other experts in various fields, and really delving down into some level enough that you can move on to the next level of uncertainty. And again, this is in the context that you already have some view of market and implementation that you start off with. So starting off, you're going to have wherever you start to focus the uncertainty, like in this example where I'm concentrating on technology, it's not in random space, because obviously what I should be doing is saying, well, if I think that this area in technology and science is going to be important, it's because it impacts all these applications over here. And generally, I see that over time, people have brought them to the marketplace through particular companies, particular structures in industry, and everything else. So you kind of, took a quick glance here, leave them fairly abstracted, and we're concentrating on, the part that we think is going to be bringing the most value. So if I'm a technologist, scientist, or entrepreneur scientist, then I'm obviously trying to create something in technology and science space in order to kind of start this process of iterating between the three elements. So I've already mentioned this, but it's not really one thing that there could be other pieces of research going on. There could be other pieces of technology in the marketplace. All these things matter because, remember, it's not just a scientific result. It's not just a piece of technology they happen to find. It's how that interacts with other technologies and technologies that may be developing in parallel. And as we pointed out in the technology part, and looking at competing technologies, you got to put all that together and see if it points in a particular direction for market application. Is the original direction, is some particular element in here that you were thinking was an application, is it still going towards that? Or does what's happening over here all of a sudden throw out some of these and you're left with fewer number of market applications as you start to understand more about the technology? And what we're really talking about here is the first pass. We're kind of saying that I did a quick initial look at these guys, which motivated my technology thing. But now, as I really delve into here and reduce the uncertainty in technology and science, it's going to affect in turn, market and of course implementation as well. I'm just drawing a circle here. Remember, there are two-way arrows between all these. So if you think about it, what you're doing is taking a first pass on some motivation and then spending a lot of time in the technology part to narrow the uncertainty. But when you throw more things out here and this gets narrower, it's automatically going to start impacting the other ones as well because options are thrown out. And these first passes are only detailed enough to reduce the greatest uncertainty. So I said that several times. That's the abstraction part. You want to not spend a thesis on each market application or particular structure of the industry or particular science yet, because you're really just trying to stay at a level of abstraction and throw out options fairly rapidly with the minimum of risk, right? That's what you're really trying to do. So let's stop there. And next time we will come in and talk about some real examples, because this all sounds fine. You may be thinking, yeah, that makes sense. But it's a little more complicated when you actually start trying to do it. So we're going to go through some real life examples that I've been involved with. And then hopefully that will add to the logic behind what I'm talking about, the principles. When I add case studies, hopefully the whole package will make what we're talking about here more clear. A lot of times people just show case studies, examples, and then hope that somehow, bright lights will shine down on you and you'll all of a sudden, realize the way things work. And I think that this background fundamental aspect of how we're thinking about innovation, how people do innovations, is really critical to understand that in a mechanistic way as best we can. And then add examples, and then I think the whole picture can be understood a little bit more easily.